welcome back to another video. Today we'll be taking a look at a broken Mac Plus with the added twist of using ChatGPT to guide us on this repair. So ChatGPT and other LLMs, or AIs, as some people call them, have been receiving quite a bit of attention recently. And it's something that I have been using, I would say, quite a bit in recent weeks and months, just for, daily routine tasks. I use it for tracking my to-do list for my chores. I've done, research with it for things. And I've also found myself using it for some vintage computer repairs. Most specifically, with the Amiga 500s I did a couple of weeks ago, and with the Macintosh 2VX I did last week. Now, I've found that with both of those types of repairs, ChatGPT often had some good information and had the right idea, but would lead me astray on a number of occasions. So ChatGPT often presents whatever it finds as factual, accurate, and doesn't always give you the best information for what you're trying to do. So I thought it'd be fun to have it try to help us repair this Macintosh Plus. So this particular Macintosh Plus I got from the uncle of one of my friends. He'd had it for years. I think he was the original owner, and now he's trying to clean out his basement. And he said that this machine, he brought it upstairs, plugged it in, it got to the flashing question mark screen. He didn't have any floppies. But then after running for a couple of minutes, there was a wisp of white smoke that came out of it, and it smelled like paper. So probably that's the reefer cap. That's a fairly standard and fairly common repair. And I want to see if ChatGPT can talk us through making this repair. So I'm going to go to ChatGPT and tell it that it should forget everything it knows about me. It should forget that it knows I know how to do vintage tech troubleshooting, and start as if it's a from scratch brand new account, so there's no history. And that should really give us a good experience on how competent ChatGPT is at helping you with vintage computer repairs. So I know, LLMs, AIs, they're a very touchy subject. Some people love them, some people hate them. There doesn't seem to be a lot of middle ground there. But I think, like it or not, they're going to be around now. I don't predict that this is just a fad and it's going to go away. I think it's just going to continue to grow. So I'm not here to argue the merits of whether or not AI is good or bad, or, if this is even AI. I have opinions about all of these things, but just wanted to go through today and just see in 2025 what it can do to help us repair vintage computers. So I actually recorded an entire video using a new setup, and when I was doing testing of that video, everything worked great. The sound was good. The video was good. And so I went ahead and recorded the whole thing. It was like 2 hours worth of video. I edited it down to about 54 minutes and found that the audio quality was terrible. I'd moved the microphone a little bit from the test to the final recording, and it picked up a ton of computer noise from the PC I was recording on, and it just really distorted the audio. I used Audacity and Adobe Podcast to help clean up the audio, and I thought it was passable. It wasn't great, but I thought it was passable. And so I uploaded that video, and the overwhelming response was, "John, you idiot, why did you upload this?" So I'm re-recording the intro here, and I'm just going to do a voiceover for everything else. So there's going to be parts where you see the other me talking, but the words that this me is saying aren't going to match up. So I'll just put myself up in the corner and try to cover up my other self, and I'll talk through the entire repair, and we should have much better quality audio this time. Oh, and if you want to see that original video, I still have it up. I just marked it as private. I'll just put a link in the description. That's got the full horrible audio, but it's maybe going to be a little better describing things that are happening as they're happening. So feel free to check it out if you want, but don't feel that you have to, because it's the same video with just worse audio.
For the purpose of this lesson, please disregard everything.
All right, so like I had noted, I'm just going to be telling ChatGPT to disregard everything it knows about me and disregard any previous chats, and it comes back and says, "Yep, I understand. We're going to be using ChatGPT 4.0 for this one. there are some different GPTs, but 4.0 is the one I've been having the most luck with in the past. So I'm just giving it the brief overview here. I'm saying, I have a Mac Plus that was given to me. The previous owner said it was on for a few minutes, but then the wisps of white smoke came out of it, and he turned it off right away. Can you help me make sure this machine's in good working order? And it says, absolutely. A smoking Mac Plus is definitely something to take serious, but it's a common issue in vintage Macs. So it's telling us to do some initial inspections here. It's telling us that we need to first do a smell test, get close to the vents and sniff. If it reeks of that distinct burn electronic smell, acrid like burnt plastic, you've likely had a failed capacitor. So I figured let's go ahead and start with that. And this is how I received the Mac Plus. I got this really nice carrying case. What it came with was the original power cord, 25 pin to 25 pin SCSI cable. We've got the keyboard, which is a really nice shape and has the numpad. It's a little yellowed, but it's in really great shape. Well taken care of. I really like pushing those keys on the numpad, apparently. I wonder what I was saying here. And then we've got the mouse that's up there. Yep, and again, the mouse is in great shape. And what I'm talking about in this mouse is that there's no like built-up dust or lint or anything on the little pads. This mouse is very clean. Again, it's a bit yellowed, but it's a very clean mouse, which is always nice to see. Keyboard cable, it's just got one small kink in it, but it's in otherwise really good shape. And here's the Mac Plus. Again, very clean, a bit yellowed, but it's in really nice shape. So we can tell that this Macintosh Plus was sold as a Mac Plus. It wasn't an upgraded 512K or 128K. We've got the reset interrupt switches on the side there. On the back, there is a sticker from the University of Wisconsin-Madison, the MACC. It talks about if you need service to call their service desk. And then it has the Macintosh Plus 1 megabyte sticker. So this shipped as a 1 megabyte Mac Plus. And opening the battery compartment, there is sure enough a battery in there, and sure enough it has leaked. So going back to ChatGPT, I'm saying, well, you didn't tell me to check the battery or anything. I wonder if that was something that we should do. It's already gone here and decided that the common culprit, probably the reefer capacitor. But I'm just looking through to see if it says that we need to check the battery, pull the battery out, if the battery could be an issue. If the battery leaked into the board, it could have destroyed some components, could have caused, that smoke that we saw. So I was just wondering if ChatGPT had mentioned the battery, and it had not. So I'm going to go ahead and take the battery out here because I know that battery shouldn't be in old Macs, GPT notwithstanding. And it's kind of wedged in there due to the corrosion, so I'm going to grab a screwdriver here and sort of try to pry it out a little bit. It's not super stuck. It came out fairly easily, but you can see that there's a line of corrosion on the back side of it. The bottom's all corroded. The top's all corroded. It's a mess. So we'll take that out. We'll come around and clean that up later, but for now, just doing the visual inspection still. We don't see anything too crazy. Going back to ChatGPT, it's telling us that we were supposed to do the smell test, supposed to do this visual inspection, and then, that is probably the reefer cap. So here's me doing the smell test. Now, I've smelled burned out reefer caps before, and they have a very distinctive smell, and it's very unpleasant. But this Mac Plus, oddly enough, smells to me at this point like a campfire. I don't smell that burnt reefer kind of smell. And it's kind of like a musty coming out of the closet smell. Not coming out of the closet, but like it was stored in a closet for a long time and had, that smell. I allude to some things later, but what really struck me here was that it smelled like somebody had taken their camping gear that had been around a campfire, shoved it in a bag, put it in the closet, left it until the next season, then pulled it out, and you get that leftover kind of smoky smell. So it wasn't a typical reefer smell, and it wasn't described as a typical reefer smell by the guy who had it. So that's kind of why I'm not 100% sure it's the reefer at this point, but that's still the likely culprit. So I've gone ahead and asked ChatGPT, okay, how do I get the case apart? Help me out. And it says, well, we need a long shaft Torx T15, and there are 5 screws, and it's giving us a step-by-step guide. So make sure it's completely disconnected from power, lay it on its face, locate the 5 screws, So there's 2 screws inside the handle, 2 at the bottom of the case by the ports, and the 5th is in the battery compartment, which we just exposed a little bit ago. So I'm using the T15 here to take those screws out. And one thing that it said is that, I'm not sure if I've gotten there yet, but it says to get the case off, pull it towards the back. Now, it also told me to lay it down on its face. So what does it mean by back in this case? I mean, I think it's clear to us that back means up, but you know, it says straight back. Pull the case, rear case straight back. Well, since it's face down, which way is back? And I'm kind of riffing on that for a little bit, making fun of GP a little bit here. But yeah, so is that back or is that back? Which way is the back? But we know what it means. GPT didn't really do too badly here. It was just kind of a fun thing. So to separate the case, they used to sell an implement called the Mac Cracker that would kind of get in there between the cracks and it would let you pop those apart. But I've often found that with just my fingernails, I can do it. And so just pull it apart and just lift the case off and take the extra 2 screws out of the handle before you lose them on the floor and step on them. They hurt. So spinning it around, I'm just taking a quick look here. The reefer cap is going to be there in the top right side of the screen, behind that coil, or I guess right next to that coil. So we're going to go back to GPT and see what it says next. All right, let's see. Once the case is off, you'll see the CRT and the anode cap, the analog board, and I told it to have the back of the case off now. And it says, all right, identify the analog board. It's the tall vertical board on the left when viewing from the rear. And this kind of baffles me because in no 9-inch compact Mac has the analog board been in the left when facing from the rear. So let me just set this thing up straight here. There's the RF shield. We'll take that off. Okay, now we're up straight. And as you can clearly see, the analog board is on the right. There it is on the right there. We're looking at it from the rear. It's on the right, not the left, GPT. Not a huge issue. I mean, if you're definitely a true novice at this, that's probably going to trip you up. But if you've got any sort of experience, that's okay. But we are acting like today as if we were a complete novice, and that's not ideal to have it completely misidentify where a component is. So now it's telling us to inspect the analog board, inspect the logic board to look for a cracked reefer cap. And now here's where I say ChatGPT could be sending us down a very dangerous path, because the CRT can retain an electrical charge even for weeks after it's unplugged. And you don't want to touch that stuff because it, could be fatal. Probably not. Probably just going to hurt a lot and maybe injure you. But, oh, there's Lane. Hi, Lane. It didn't mention that. It said, take the analog board off. Disconnect all the cables. Take the analog board off and inspect it. Not such a good idea. So I asked it, knowing this. But if I was a novice, I wouldn't know to ask this. I would, say, okay, well, I'm going to unplug all these cables. And here's a red cable with a weird connection on the end. I'm going to unplug that. That's a really bad plan. So I asked it, I said, what do I need to do to stay safe? And it said, oh, well, you need to discharge the CRT. And it says, I'll tell you how to do it later. Okay, well, we'll get there. But one other thing I'm talking about here is that Apple puts this plastic thing on the back of the analog board as an insulator to keep you from touching something that is energized. So if it's plugged in, if it's off, there still could be power on there. And my note here was that if somebody had worked on this previously and not reinstalled the plastic guard on the analog board, then even just inspecting it, you grab it and move it around, you could grab the wrong place and zap yourself. But GPT didn't warn us that that plastic panel needed to be present. So a couple of misses there from GPT that could have, serious consequences. And not just like, you're going to ruin your Mac. Like, it probably wouldn't, but it could possibly kill someone. So anyway, I'm talking about the reefer there. It doesn't look good from this vantage point. And now I'm talking about the anode cap that goes into the CRT. And we're going back to GPT and asking it now, how do we properly discharge the CRT? You told us that we need to discharge the CRT, but you didn't tell us how. How do we do it? And I've gone on now, I guess, next talking about the capacitor that I found, the RIFA. It's a 0.1 microfarad X-type. It's cracked and swollen, and it's near the mains input on the analog board. And GPT is telling us, oh, yep, that's probably the issue. Here's some likely modern replacements, what the specs of the existing ones are, and it can tell us that we can replace the Y caps as well. And it's warned us not to power it on again, which this is all good stuff. Like, it's given us the specs we need, it's given us an optional thing to do, and it's told us not to turn it on. So now I'm asking how to get the analog board off, and it says we'll need the Phillips screwdriver, needle nose pliers, and we need to discharge the CRT. So I got tripped up here a bit as well, because it says step 1, disconnect cables. And this is what I was talking about earlier, so I guess I got ahead of myself. But if I'm just going to go through these one step at a time, the first thing it says is disconnect cables. Well, that red cable, I need to disconnect it, right? It's a cable, it's coming from the analog board, and that's the one going to the anode cap. You disconnect that, and you touch it, and you zap yourself, and that's not good. So this is, again, bad advice here, but it's not truly bad advice because it's just advice that was given in the incorrect way. So it didn't say disconnect all cables except the anode cap, but that drill we did in middle school and elementary school, where you have the long list of instructions that says, do this, do this, do this, do this, and one of them was like, crumple this paper up and throw it at your teacher, and you get to the end, and it says write your name at the top and turn it in. And the very first instruction was carefully read all instructions before completing anything. And there'd be kids throwing paper at the teacher, and then like 3 or 4 kids would just turn it in. So it's kind of that exercise where with GPT, read through the entire answer first before you actually do any of the work, because it says 1, disconnect cables, but right after that it says the anode cap has got to be done carefully. And then it goes on to say, what if you want to leave the CRT wired and you don't want to disconnect the anode cap? That's not a great idea, because that's going to lead to potentially breaking something or potentially having it pop out when you don't want it to. It should be suggesting that you leave that connected. So I did ask it what I should be doing to discharge the CRT. And this is power off and unplug the Mac, locate the anode cap, get an alligator clip it to the implosion band, which it doesn't call the implosion band, but I think it calls it like the outer band around the CRT. Clip your wire to your screwdriver, and then use your screwdriver and slip it in underneath the cap and touch the metal, and that should discharge it. It also talks about there are tools you can use, in which there are, and I decided that I would just go ahead and do it the way it said, since that's normally how I do it. I've got up above my head there, I've got these clips. I'm going to clip this to the implosion band, clip the other end to a screwdriver, and just kind of slip it in there. Now if you buy the actual tool, it'll tell you what the residual voltage was, but this seems to work pretty well. One thing I always do when I'm doing this is I wear rubber-soled shoes, and I held those up just a second ago to show that that's what I was putting on, and I keep my left hand behind my back, so that way there is no path through my heart to complete the circuit. And you saw me reach in. That's after I knew I had discharged it. This one didn't actually have any charge left. I didn't hear a tick or a crack or anything when I touched the metal, but if they are charged up, you'll get a crack or a hiss or a tick or a pop or something. They all act a little differently. But you'll know. If it was charged and is no longer charged, you will know. All right, so that all being said, we've got the anode cap off. We've safely discharged the CRT. So as long as we don't plug it back in, we're pretty safe from here on out. So it's going to have us remove the analog board here. It's talking about now how there are screws in each corner of the analog board. It says there's usually 4 Phillips screws, 1 in each corner of the board. And that is absolutely false. There's never screws at the top back or the top front. So I don't know where GPT would have got this information. Maybe this is one of those instances where it's just making it up, because typically circuit boards do have a screw in each corner. But the 9-inch compact Macs have never had screws holding anything together at the top of the analog board. There's a number in the bottom and the middle, but definitely not at the top. So again, this isn't a huge problem because, you can look for screws, and if you see them, you take them out. And if you don't see them and the board doesn't come, you look a little harder. But I thought it was just kind of interesting how it talks about how it has these screws at the corners. And I riff on GPT for a while here, making fun of it, saying, oh yeah, 4 screws in the corners. So it was this point where I realized somebody had actually been into this case before, because there were some areas that should have had screws that didn't, but none of them were in the top 2 corners. So I'm going to go ahead and pop out these 4 screws. There's 2 there where my left hand is, and then 2 on the left side right under the high voltage warning triangle. Yeah, right there. So with those out, we can pull the analog board out. We've disconnected the neck connector, the connection to the digital board, the anode cap, the grounding strap, and that last thing was the what's that called? I forgot. The connector that sends the electrons, the magnets, pulses the. Yeah, I totally spaced it. Sorry. Anyway, we got it off. So what I'm seeing now is that there's a bunch of goo on the bottom of the board next to the left of the power input there. Also some on the case. And at this point, I'm not 100% sure if it's from the battery or if it's from the REFA or if it's from something else. But with a little bit of isopropanol here, it comes off really easily, which means it's pretty fresh, which means it's from the REFA. So that REFA cap cooked itself, let out the magic smoke, and gooed itself all over the board here, as well as the metal case there. So with this kind of stuff, it's always important to clean it off as soon as you can, because it can be corrosive to the board, and it can start eating through it, and it can cause other things to fail later. So you want to get off as much as you can. Luckily, in this case, it was fresh, so it came off really easily. The brown coloration there isn't from that. The board actually just had a brown section there that happened to kind of line up with it, so that was nothing to be worried about. All right, so it's talking about the REFA capacitor. I've asked it how to remove that capacitor, and it says locate and desolder the bad capacitor. Well, me being the novice, I'm like, well, I can't see the underside of the board. How am I gonna desolder that? And didn't give me the instructions to take that panel off, which I'm doing here. Unfortunately, this particular panel is held on just with 2-sided double sticky foam, which is how they did it with the original Macs. And later Macs use like little plastic kind of rivet tab things to hold it in place. They never use metal. So anyway, I've asked GPT here how to get that off, or how do I get to the bottom of the board, and it says I'll just take it off. There's retaining tabs. They're either plastic or it's held in place by some bent metal. Neither of those are true for a Mac Plus. It's this double-sided sticky foam. So again, it gave us the right kind of idea, but it is pretty far off base there. So it says if it was the plastic ones, we could cut them or use an X-Acto knife or a hobby file, and that's not the case either. The ones that actually have the tabs, you can take them and squeeze them from the backside and pull them through, so you can reuse them. If you cut them, you can't reuse them. But again, not applicable to this Mac because it's got the foam. So we're just gonna sort of peel that foam apart and get that backside off. And it says, once we're done, we have to reinstall it, which is great because you should always reinstall it. And it says use hot glue or tape. Okay. So now I've asked it how to remove the REFA, and it's telling me what I need. Identify the pins, heat one pin one at a time, wait a few seconds for the solder to fully melt, and then use a desoldering tool or use a desoldering braid. I do have a solder sucker, but I don't have one of those really nice Hakko ones, so I don't use it too often because it doesn't work great. And I've had a lot of luck with the soldering braid, so that's what I end up using. And then it tells us to wiggle the capacitor side to side and to pull it out that way. So it wants us to heat up one pin at a time, use a solder braid, and get all of that old solder off of there. So one thing that's nice about working on these old Macs, I just put some flux on the board because you always should use flux. But one of the nice things about working on these old Macs is they all use leaded solder, which has a much lower melting point. And so we can get that to come out pretty quickly and pretty easily. And so while I'm waiting for my soldering iron to heat up, I dug through my parts bin and I found two Rifa style capacitors here. The one on the left, the black one, is 0.22 microfarads at 275 volts. The one on the right is 475 volts, and I don't recall the other specs about it, but I'll punch those into GPT here in a second. I didn't have the exact matching capacitor, and I wanted to ask ChatGPT of these two that I found, which one or which ones would work. And so it found that the 275 volt 0.22 microfarad X2 cap would be good. The 104K 440 volt X1 type cap was not suitable for AC line filtering. So that's good. It did give us good information here because we don't want to use the wrong capacitor. And yeah, 0.1 microfarad was the original. 0.22 microfarad is close enough where it's not going to be an issue, and the voltage rating is the same. So then I go on to ask it, well, how do I know which side to put in which hole? And it says, well, good news, Rifa caps aren't polarized, and you can put it in either way you like. The reason for that being is that it's on an AC line, so it can't be polarized because every 1/60th of a second, it's getting the polarity reversed. So if it did have polarity, it wouldn't make it more than 1/60th of a second. I guess it could make it up to 1/60th of a second before it exploded, but it could not make it 1/30th of a second. Something else here that I'm going to ask ChatGPT about is the replacement cap is not as wide as the original cap, and I ask it for some advice on how to make it fit, and we'll get to that, I guess, in a minute. So right now I'm desoldering it. Yeah, so I got the flux on there, and we're using the desolder braid, and that's just sucking up all that solder. I didn't realize that all the smoke from that was coming right into my face at the time. That's not good. I do have a vent fan that I usually use when the currents are blowing it towards me. I should have fired that up. That's not healthy at all. But I survived, I guess. I don't know. Maybe I've got lead poisoning now. So I do talk about the solder that I'm using to put the new solder on eventually, but one of the things that is important to note now is that we didn't apply any fresh solder to this because this board was in good shape and because it was the low heat solder. So just a little bit of flux, and then we can get all that solder off. Unfortunately, or fortunately, I don't know, the pins were bent so that it wouldn't come straight out. So I'm using side cutters here to straighten the legs, when in fact I could have used side cutters here to just cut those extra parts of the legs off, and it would have made things a little easier, but that's okay. We got it out in one piece. Oh, just kidding. We got it out in two pieces because it was cracked and exploded. So you can see it actually had swollen, cracked, and blown a piece of itself off, and then leaked its guts all over. So that's what a failed Rifa cap looks like. There's a better view of it. Yeah, that's the top that had got blown off. So clearly bad. Almost at this point, or at this point, almost 100% sure that's going to be the problem with this Mac. Definitely a problem. And given that it was working until it wasn't, very likely that it's going to be the only problem. All right, here's where I'm talking about the width. And so I'm going to ask ChatGPT, how do I make this fit? And the answers are kind of both hilarious and scary. All right, come on, John, go faster. Pull up that GPT window. Let's see what we got. All right. Type it in. Okay, so I will use the 0.22 microfarad cap. Which leg goes in which hole. So here's where I talk about this. So This is actually a filtering cap across the AC line. So this is a capacitor. This capacitor that's connected from hot to neutral on the AC line. And this isn't used to reduce noise into the Mac. This is used to reduce noise coming back out of the Mac. So again, it doesn't matter which way it goes, but we just need to pop it in there. And one other thing, and I think I talk about this later. I do talk about it later. So we'll wait till we get to that, and then I'll talk about it. So now I'm cleaning off the rest of the reefer that had exploded. Once I pulled the capacitor up, I could see that there was even more stuff under where it was. And just another cleanup down there at the bottom, because we really don't want any of that stuff stuck to the board. So it's looking pretty good. Yeah, I'm going between the components there, trying to get every last drop of reefer goo out. All right, so here we are explaining the width thing. And here's where it gets fun. So this one is not as wide. Option 1, bend the legs. Great option. Option 2, use one hole and drill a new hole. You can see me just looking baffled. Like, why would it even suggest that? Is that feasible? Yeah, of course. It's a single layer board. You could drill a hole through it and then connect it on the backside if you wanted, I guess. But geez, that's a really terrible suggestion. And you have to be really careful doing that, and it shouldn't even suggest it. And option 3 was to use some bodge wires, or wire extensions as it calls them. Not a huge fan of that, because this is a hot to neutral connection, and you don't want bodge wires kind of just hanging out that could pop loose and short something somewhere. So option 3, not the best idea, but it could work. Option 2, terrible idea. Look at me laughing about this. All right, so I've decided to go with option 1. I'm just going to bend these legs outward a little bit, and that should make things much easier. So we'll just shove that in there, bend the legs over, and then we'll get some solder on there. So I didn't use any flux to resolder. There was some extra flux on the board already, but the solder that I'm using is rosin core flux, and the rosin core solder, and the rosin core is flux. So that is something that we need to make sure we clean off. The flux I typically use, it's not part of the solder, is no clean flux. Oh, good point. Right here I'm talking about the connector to the digital board. I'm going to reflow all of those pins, because very often on Mac Pluses, those get broken and end up with cold solder joints just due to the stress of the machine or being hot and cold. So I'm just reflowing them all quick. I thought I might have even seen like the fourth one in might have had a cold solder joint, or was just about to. There was certainly a crack in it. So just reflowed that stuff. But then we want to make sure that we carefully clean up all of the flux. So like I was saying, the flux that I use for doing removal and new stuff is no clean flux. So technically you don't have to take it off the board, because it's not supposed to be corrosive later. But I always try to get as much off as I can. But the rosin core solder, the flux that's in the solder, can be corrosive to the board, and if you leave it on, it can start eating its way through traces, and then it will cause some additional damage that can be much harder to fix. So always clean up your flux when you're done, and don't leave it just sitting on the board. Also, because it's sticky and it's going to attract dust, and it's just going to be problems later. So clean up your flux. All right, so we've got our replacement reefer installed, cutting the legs off of it, and now I think we're going to go back to GPT and see what it tells us to do next. And what it's going to tell us is that we're good to do a safe power up. So it wants us to reinstall the analog board, reconnect the cables, check for misconnections. And here I am, again, asking about the flux. So this is something that I knew that it didn't tell me to do. But yeah, it's saying the exact same thing I just said, is that flux can become conductive, it's sticky, even no clean flux is worth removing, and to use isopropyl alcohol, which is what I've done. So again, like, GPT knows these things, and it provides good advice if you know what to ask it. So as a novice coming in, I wouldn't have asked that question. I wouldn't say, oh, well, I just put the flux on and I put it on and then I put the board back. But, having done the occasional Mac repair in my past, I understand about some of these issues and I'm able to ask better questions, and it does provide the right answers. So, it's not quite leading us to the correct direction to get everything done, but when we push it and press it for more answers, oftentimes it will give us at least one good option out of three, if not the good option only. So I'm now talking about putting the panel back on. I've used some double-sided sticky tape, and then I was talking about how there's holes in it. We want to make sure those are lined up, because those are what you can use to adjust the picture while it's up and running. And of course, you don't use metal screwdrivers. You can use ceramic or plastic, anything that won't short you out. So I asked it what I should do next, and it said put it back together and try it out. And I said, no, hang on. Let's take this digital board out and take a look at that, because there could be problems. So I pull it out and I see that it has 4 megabytes of RAM. So somebody definitely has been in here and upgraded the RAM to 4 megabytes. Those would have been 256K sims in its original config. And the resistor up here has been cut, indicating that it's not a 256K RAM config. It is at the 4 meg max for a Mac Plus. So somebody had been in here, upgraded the RAM. Board looks like it's otherwise in really good shape. A little dusty, not too bad. Luckily, no battery goo had leaked on it. Luckily, no reefa goo had leaked on it. So I think we're good to put this board back into the case. One thing I caught here, and the light's kind of blocking it. This is where I finally saw the goo that was on the case, on the chassis itself. I'll put my hand up and block the light in a second. You can kind of see it in front of my hand. There's brown goo. Yeah, right there. So that was from the reefa. And again, we want to clean everything off because we put the analog board back. It's going to touch it. It's going to transfer back to it. And we don't want that. We want all that stuff gone. So just a little touch up here. Get that all cleaned up. Get the edges. Yeah, almost think we got it. All right. Throw that Q-tip out. Oh, I guess I wasn't quite finished. Last Q-tip, hopefully. Boy, I really featured cleaning off this piece of metal. I don't know why I spent so much time in this. I was probably saying something really profound and important at this point, but, well, lost the time, I guess. So now I'm just getting the floppy ribbon out of the way so I can put the board back. So the board just slides in and out. And the later Macs like the SE and the SE30, it goes up a little bit and hinges, but on the Plus, it has to go all the way down. Spin it around, plug in the floppy drive, spin it around again, and now we can reinstall the analog board. The brightness knob is on the bottom, so that kind of fits into a hole, and then you can reattach the screws. So I had 4 screws that I'd taken off, and it was missing some, and I'm just putting the 4 back on. And I don't really know what I'm saying here. Yoke connector. That's what it's called. That's what I couldn't remember. It's the yoke connector. So I didn't plug it in first here. I should have. I realized that mistake too late, and I'm like, I'll just go ahead and do this and say I'm going to plug the yoke connector in now. But I would like to have plugged that in before I put the board on, because it's kind of hard to reach in there. And you can kind of risk, breaking the neck too doing that. So the first thing I reconnect is the grounding cable, because that's really important. If you power it up without the ground, there's going to be problems. And it's easy to forget. It's just one cable, so I always do it first. That was the yoke connector, I think. And then I realized I'm going to clean the the anode cap area. The rubber had sort of started to flake off a little bit, so just cleaning that up before we put that back on. Yep, get that back in there. And then the connection from the digital to the analog board. Looks good. The neck board, which is not a board at all in this case. All right. So I think we're ready for a power on to make sure everything's working. I'll grab the original power cable. Plug that in there to the power strip. Plug it in the back. And here's where I remember that that Refa cap that we just reinstalled, it's always energized when the machine's plugged in. It is in line before the switch. So I go on here saying like, well, it didn't explode. I haven't turned it on yet, but if it was going to explode, it would have, because it's always energized. So I'm saying something like, if you've got a classic Mac Plus like this and you haven't replaced the Refa, unplug it when you're not using it, because you don't want it to start smoking and causing problems when you're out of the house. It probably won't burn your house down, but the smoke is acrid and you don't want that floating around unattended. So anyway, I hit the power switch, and to no one's surprise, it powers right up and we get the flashing question mark. So that looks really good. Turn it off. Now we can reassemble, I think is what we do next. Oh, it looks like we're going back to GPT. I think we're going to ask here about the Refa, if it's always energized or not. So what's interesting here is that ChatGPT says no, it's not. It's after the power switch. I'm like, I don't think that's the case. Let's let's go to Google and see what the internet says. And then I forgot that Gemini exists because I just am used to ignoring it. But yeah, Gemini says that it can, blow even when the machine is switched off. So we've got two different LLMs, two different AIs. One says it's after the switch, one says it's before the switch. And, one of them obviously is wrong, but they've both presented this as, factually accurate information. So anyway, I'm like 98% sure it's before the switch, and unplug your Mac Pluses if you haven't replaced the Refa. All right, so I think I must be still going off about how Gemini and ChatGPT don't agree, and I'm just laughing about it. All right, come on, John, let's put this thing back together. We're going here. Come on. I'm very very animated with this this riff on GPT. Where are we going? We're gonna click on that. Nope. Now we're gonna reassemble. So put the RF shield back, put the case back on, and just, I believe I said, plunk her down. See, I just plunk her down. Then you've got the 5 screws. The black ones go on the bottom by the ports. The silver ones go on the handle and in the battery door. So I'll get those all put back and tightened down with my long-handled Torx T15. And now I want to clean out the crusties from the battery compartment. Both of the contacts there have the crusties, the crystals, and both of the contacts have rusted. I'm not going to be running a battery in this Mac Plus, so I don't need to worry about getting it nice and shiny. Just trying to get the crap out so that it doesn't, fall into the case later, and prevent any sort of future damage. We probably should neutralize the alkaline stuff with some vinegar, but there isn't that much left, and just using the isopropanol kind of took care of it. So we'll put the door back on, make it look pretty, and now we're ready for a full test. So I've got the external hard drive plugged in there, and I'm like, the camera's not really capturing the picture very well, but going about this, about the Finder, because this is System 6, I think. And yeah, we do have the full 4 megs of RAM. So now I'm saying this machine is fully fixed. Simple as changing a cap. So I think we had pretty good luck with GPT. It did, get us to almost kill ourselves. Had we followed his directions exactly and had the CRT been energized. So back to GPT. What are we going to ask next? Oh, yeah. I said, so we had the Mac fixed. Anything you'd like to say to our viewers? And it gave me a script to put in my video. And I said, no, don't want a script. You're talking to the viewers. Go ahead and say what you want. And it says, hey folks, if you're watching this, we just brought a vintage Mac Plus back from the dead. The culprit, one of those lovely old Refa capacitors that decided to go out in a puff of smoke, as they often do. If you've got a classic Mac and it hasn't smoked yet, it's probably just waiting for the right moment. So open it up, take a look near that power input, and if you see one of those cracked plastic blocks, replace it before it stages a fireworks show. Big thanks for hanging out while we tore this thing down and got it running again. Keep your soldering irons hot, your CRTs to ghost, and we'll see you next time. And then it says, you want one that's more sarcastic, heartfelt, overly dramatic like an Apple event? I can lean into any vibe you want. And I'm like, yeah, I just wanted you to talk to the people watching this video. I didn't understand what I was asking, I guess. All right, so then I go on to talk about some other times I've used GPT in the past. So the first one up here is when I was working on the Macintosh IIvx. So the IIvx has a 68030 processor in a QFP package, and I gave it the exact model number of the processor I had, and I said, I need to find halt, I need to find reset, I need to know what the address lines are, I need to know what the data lines are so I can put my oscilloscope on them and see if any of those are causing this machine not to boot. And it gave me some pins, and I said, oh, okay, you know, pin 11 and 12 are halt and reset or something, as an example. So I went and checked pin 11 and 12, and they were both set to, I think, high, which is correct. And I said, okay, well, let's check the data line. And I went and checked the data line. No, I think I went to check the clock line next, and the clock input line, and I could not get a clock input signal. I'm like, oh, well, then something wrong with the oscillator. The crystal's bad in this machine. And I thought maybe a bit better double check on my working IIvx to see if it's got the same problem or see what it's supposed to look like. And it looked identical. So I'm like, all right, well, this isn't the clock signal then. And I went, tried a bunch of pins, and I couldn't find it anywhere. And I went back to GPT and said, all right, you told me the clock pin was pin 11, but it's not pin 11. What's the clock pin? I need to know. You have my model number of my CPU. What's the clock pin? And it said, oh, yeah, clock. It's on the CLK clock input 2. And pin 23. It's not pin 23 on the package that I have. And no matter how many times I asked and said, that's not right, it couldn't give me the right answer. Now, to be fair, I went out and Googled this myself, and I had a really difficult time finding out the actual pinout of the 68030 that I have in the IIvx. I did eventually come across an Amiga site, because Amigas used the 68K line as well. So that's what I'm pointing to here. This site, it says the clock is pin 6. So I said, okay. So I put my oscilloscope on pin 6, and sure enough, there was the clock signal, 31.949 megahertz or whatever. So, it was leading me astray, and I was spending all this time, troubleshooting, why isn't there a clock signal? I tested the oscillators, I tested the traces, and I wasn't getting tone to that pin because it was the wrong pin, and that's not where it was supposed to go. So I wasted, a bunch of time thinking that this was a really simple question, what pin is the clock on? And it just completely led me astray, and I spent hours trying to troubleshoot this, between toning it out and testing the oscillators. And these things aren't easy to test because the power supply is modular and clunks down on top, so you got to work from the bottom. Yeah, I was a little angry. I used some choice words with GPT in this one, which I don't show in this video, but trust me, I scolded it. So then, it's asking me here, well, have you checked reset? Have you checked halt? And I said, you darn well know I've checked them both. You had me check them both. They're both high. Why are you having me check them again? And I said, oh, yeah, right. I did have you check them. So it's you got to be kidding me. You told me to do a thing. I did a thing. And then sometime later, you tell me to do the same thing again. And I found that to be the case a number of times where it would just kind of get stuck in a loop where it would say, check this, I'd give it an answer. It'd say, check this, I would give it an answer. And it would take me back to the first one. Well, if it's not that, it's got to be this. So, we never did get this IIvx working, me and ChatGPT. I did a ton of troubleshooting, and I learned a lot about using ChatGPT for legacy vintage computing repair. But it's still on the list of something we got to fix. So, yeah, and it's having me check the address lines, which is great. But this is all information I found and fed into it. So, it wasn't great. But then we're on now to the Amiga video. So I had two Amigas, two Amiga 500s. They're both Rev 5, which takes a big ROM, which looks like this, actually. These are big ROMs. And I was asking it if I could make an adapter to use a ROM that I happen to have on hand, or if I needed to, buy some of these to put in there. I said, oh yeah, you can use a 27C512. Just, put it in the ROM slot incorrectly. Put it either bottom aligned or put pin 1 into pin 3 of the socket. And I can't do that because this ROM is so big that if you put pin 1 into hole 3 of the socket, it's not going to be bottom aligned, and vice versa if you put it at the bottom. But you also can't just slide ROMs around like that. That's not how they work. There's electrical, VCC connections, there's data, there's addresses. Sure, maybe like a 1 in a million chance you can move a ROM around and it'll work in a different socket, but don't count on that. And if GPT ever tells you to put the wrong chip in a socket that it's not supposed to go into, don't do it. So anyway, in this particular case, it's do these two things at the same time, and that was physically impossible. You can't put pin 1 into pin 3 and have it be bottom aligned. So it was just, and both of those pieces of advice are bad. So it was 3 strikes all at once. So that was an interesting thing there. I think I talk about this for quite a while because, I go on and talk about just some of the ChatGPT stuff, but I think I'll go ahead and end this recap of the video here. So this was an interesting format. I intend to try to use this format again in the future, but with actually good sound. And hopefully I won't have to do another Mystery Science Theater 3000 voiceover like I've done for this video. So anyway, thanks for watching. Again, if you want to watch the original in all of its horrible audio glory, check the description for the link. But thanks for hanging out with me while I watch my own video and narrate through it. So have a great day, and we will see you next week with good audio.
Hi guys! Make sure to like and subscribe and watch more of our videos later. Bye!